that was vivacity from our side. We'll look forward to your participation in Cultural Council as well as in vivacity later. We'll have more sessions with you so that we can have your involvement as much as we can with us. Hope you had a great time. Came to know you knew about all of us, what we do at Cultural Council. For any queries, you can feel free to contact either me or Kimi or any of the coordinators. We'll circulate the list to you that put up on the notice boards. We'll have sessions, ask them to have sessions with you, one-to-one sessions, so that all those interested, feeling shy at present moment to come out, can come out later. See you at your freshers. Thank you.
The honor of having with us Professor Muthukrishnan. His credentials are as impeccable as his suggestions to improve the quality of education given to India's assembly line of aspiring infotech professionals. Currently, the Deputy Director of IIT Madras, Professor Muthukrishnan, the President of Computer Society of India and a member of Tamil Nadu Government Infotech Task Force, has over 30 years of experience in the field of software and IT. He has been a visiting faculty at Wichita State University and the University of California, San Diego, and a visiting research scientist at Carnegie Mellon University. I hereby invite Professor Muthukrishnan to share his views on the stage.
10 past 10, so we have about 45 to 50 minutes. I come from a faraway place and I took this journey and the trouble to come for two reasons. One, I wanted to meet all of you guys, all of you young friends, future engineers, men and women. Also, the invitation was from your director, Professor Gokhale, and your dean, Professor Ravi Prakash. I've been to this institute some years ago, 4 years ago, and at that time, Professor Sanghi was the director, and I went back with some very pleasant memories. So I said I should come again. In my introduction, a few things were said, but what was not said is that I have a secret to keep myself young, which I want to share with you. And that is simply through the joy of learning and sharing. Only two words, learning and sharing. That's what keeps me going. Most of you will guess my age probably a little bit on the lower side. And that confirms that I keep myself young. How old do you think I am? What's my age? Okay, you're on the dot approximately. Good. The other thing that has not been said about me is that I enjoy writing programs, reading code, analyzing code. I still write programs. It's something I started in mid-60s. It's almost going to be close to 50 years now. So there were years of lot of peak activity. I used to write and work with programs for 12, 14 hours a day and so on, but now it's come down. But I still do at least on an average about 4 or 5 hours of programming, reading program, changing program, modifying and so on every week. So that's about me. But there's a lot to say, but I have to be very, very, very choosy, very selective. First, congratulations to all of you in choosing to come to study engineering and to come to this institution, Lakshmi Nivas Mittal Institute of Information Technology. So you made a good choice. I'm sure it will work for you very well, provided you make it work for you. That's important. For anything to really come out well, it takes both the context in which you are placed to support you, and also you also need to support and bring out the effort and the grit, the determination to face the challenges. So that's the mantra of success. What is the most precious thing in life? what is the most precious resource thing in life? I want a couple of answers. Knowledge. Yeah? Friends. Huh? You have to speak louder. Happiness. Huh? Family. Time. I like that answer. Yeah. Culture. Health. Activities, yeah. Okay, I think all of them are valid answers, but if you ask me to just say one, I would say time. Time is the most precious thing because it's something you can't store and later use. If gone means gone. You can't manufacture it, and it is given fairly and equally to everybody. You know, I can't lend you my time, you can't lend me your time, and we all have equally. So I think you must make the best use of your time, or because you want to please your neighbors. That may be also a motivation, but ultimately it's self-actualization. You have to drive yourself. Okay? You're capable of that. Don't underestimate yourself. You're very capable of that. Make every day count for you. You're at most of you, all of you are at an adolescent age group. Adolescent. You know what is meant by adolescence? We have all gone through it. I've been an adolescent. Your director has been an adolescent. Your professors, deans. Right? We all go through that stage. So adolescence is when the world outside opens up to you in myriad ways that you are not aware of. Right? You are not sensually, in terms of sensory stimuli response, not prepared. It's natural. It's not something that is, no. But you have to eschew it. Eschew it means, carefully manage it. Very important. Otherwise, you can get distracted. You can lose focus, concentration, right? And then when such things happen, it happens rarely to a few, you tend to give excuses, right? Doesn't help. So while you go through this inner awareness of being an adolescent, you also have to make your intellect rise, come above that, and so you be in charge of yourself, take control of yourself, be in charge of yourself. Don't let outside stimuli and outside factors influence you emotionally or guide you into unthinking, unfocused actions. Very important. Maybe most of you don't need the message. I might be carrying coals to Newcastle, like they say, right? Or carrying coals to, what is a good coal field in India? Singareni. Yeah, so keep that at the back of your mind and make every day count for you.
I'm a medical illustrator, and I come from a slightly different point of view. I've been watching since I grew up the expressions of truth and beauty in the arts and truth and beauty in the sciences, and while these are both wonderful things in their own right, they both have very wonderful things going for them. Truth and beauty as ideals that can be looked at by the sciences and by math are almost like the ideal conjoined twins that a scientist would want to date. These are expressions of truth as awful things by meaning they are things you can worship. They are ideals that are powerful, they are irreducible, they are unique, they are useful, sometimes often a long time after the fact. And you can actually roll some of the pictures now because I don't want to look at me on the screen. Truth and beauty are things that are often opaque to people who are not in the sciences. They are things that are that describe beauty in a way that is often only accessible if you understand the language and the syntax of the person who studies the subject in which truth and beauty is expressed. If you look at the math E equals mc squared, if you look at the cosmological constant where there's an anthropic ideal where you see that life had to evolve from the numbers that describe the universe, these are things that are really difficult to understand. And what I've tried to do since I had my training as a medical illustrator, since I was taught animation by my father who was a sculptor and my visual mentor, I wanted to figure out a way to help people understand truth and beauty in the biological sciences by using animation, by using pictures, by telling stories, so that the things that are not necessarily evident to people can be brought forth and can be taught and can be understood. And students today are often immersed in an environment where what they learn is subjects that have truth and beauty embedded in them, but the way they're taught is compartmentalized, and it's drawn down to the point where the truth and beauty are not always evident. It's almost like that old recipe for chicken soup, where you boil the chicken until the flavor is just gone. And we don't want to do that to our students. So we have an opportunity to really open up education. And I had a telephone call from Robert Liu at Harvard in the molecular and cellular biology department a couple of years ago. And he asked me if my team and I would be interested and willing to really change how medical and scientific education is done at Harvard. And so we embarked on a project that would explore the cell, that it would explore the truth and beauty inherent in molecular and cellular biology so that students could understand a larger picture that they could hang all of these facts on, that they could have a mental image of the cell as a large, bustling, hugely complicated city that's occupied by micro-machines. And these micro-machines really are at the heart of life. These micro-machines, which are the envy of nanotechnologists the world over, are self-directed, powerful, precise, accurate devices that are made out of strings of amino acids. And these micro-machines power how a cell moves. They power how a cell replicates. They power our hearts. They power our minds. And so what we wanted to do was we wanted to figure out how we could make this story into an animation that would be the centerpiece of BioVisions at Harvard, which is a website that Harvard has for its molecular and cellular biology students that will, in addition to all the textual information, in addition to all the didactic stuff, put everything together visually so that these students would have an internalized view of what a cell really is in all of its truth and beauty, and be able to study with this view in mind so that their imaginations would be sparked, so that their passions would be sparked, and so that they would be able to go on and use these visions in their head to make new discoveries and to be able to find out really how life works. So we set out by looking at how these molecules are put together. We worked with a theme which is you've got macrophages that are streaming down a capillary and they're touching the surface of the capillary wall and they're picking up information from cells that are on the capillary wall, and they are given this information that there's an inflammation somewhere outside where they can't see and sense, but they get information that causes them to stop, causes them to internalize that they need to make all of the various parts that will cause them to change their shape and try to get out of this capillary and find out what's going on. So these molecular motors, we had to work with the Harvard scientists and data bank models of the atomically accurate molecules and figure out how they moved and figure out what they did and figure out how to do this in a way that was truthful in that it imparted what was going on, but not so truthful that the compact crowding in a cell would prevent the vista from happening. And so what I'm going to show you is a 3-minute Reader's Digest version of the first aspect of this film that we produced. It's an ongoing project that's going to go another 4 or 5 years. And I want you to look at this and see the paths that the cell manufactures, these little walking machines. They're called kinesins that take these huge loads that would challenge an ant in relative size. Run the movie, please. But these machines that power the inside of the cells are really quite amazing, and they really are the basis of all life, but because all of these machines interact with each other, they pass information to each other, they cause different things to happen inside the cell, and the cell will actually manufacture the parts that it needs on the fly from information that's brought from the nucleus by molecules that read the genes. And no life, from the smallest life to everybody here, would be possible without these little micro machines. In fact, it would really, in the absence of these machines, have made the attendance here, Chris, really quite sparse. This is the FedEx delivery guy of the cell. This little guy is called a kinesin, and he pulls a sack that's full of brand new manufactured proteins to wherever it's needed in the cell, whether it's to a membrane, whether it's to an organelle, whether it's to build something or repair something. And each of us has about 100,000 of these things running around right now inside each one of your 100 trillion cells. So no matter how lazy you feel, you're not really intrinsically doing nothing. So what I want you to do